The African continent is known to have over thousands of plant species that call it home. Among those plants, many of them are grown and harvested by human farmers, who use these crops to feed their vast communities and boost their economies. That is where I come in. I'm a virus, which means I'm neither living nor dead. I just kind of vibe with what goes on around me. As someone who's been vibing for over 300,000 million years, I consider myself to be a self-made virus. Unlike most of my other fellow virus family, I don't infect humans, at least not in the traditional sense. I don't travel through your droplets or blood, and I'm not in the company of the old Grim Reaper, so there hasn't been a lot of hysteria over me by you humans. Instead, I like to infect the crops that are grown by farmers. Cassava is the third largest source of carbohydrates for humans in the world. This makes it a really easy target for me because you humans like growing so much of it. But trying to get my little virus body into one of these crops requires a lot of work, so I require some help from a few little friends. In Africa, there's a tiny little bug called a whitefly that loves to eat on the leaves of plants. Whiteflies are enormous to a virus like me, spanning 2 millimeters in length. This size is perfect for my 22 nanometer sized body. Okay, I know what you're thinking. To a person, that may not seem very big, but that just helps me in the end because it makes it harder for humans to spot them. You see, my big friend the whitefly can be referred to as a causal agent, because it is through the whiteflies that I am able to attach myself and infect the cassava crops. Just a single leaf of cassava can have over 100 whiteflies attached to it. When there are so many whiteflies in Africa that want to eat the cassava leaves, it's easy for me to be able to jump from plant to plant because the whitefly does all the work for me. You know the saying, when it rains it pours? You could apply that to viruses like me as well. One thing us viruses are especially good at is that we constantly change via mutation. That makes it easier for us to adapt to new changes in the environment. One of my mutations has been referred to as cassava brown stake virus disease. When this mutated virus infects cassava crops, it attacks the roots of the plant. The virus is so severe that the root ends up rotting and the crop becomes inedible to humans. The biggest consequence of a virus like me is not that I attack humans directly, but I can render entire crop yields useless. Up to 24% of crop yield reductions in Africa can be attributed directly to viruses such as myself. To put it another way, that's up to 28 million tons of crops gone to waste. To put it on an economic scale, nearly $3 billion in revenue is lost to me yearly. At the end of the day, I'm just a simple virus that's trying to make my way in this universe.
As we've seen with our little friend here, scientists, like myself, have worked to discover new ways to decrease this deficit of revenue caused by this little virus. In order to do so, they have used phytosanitation, which is the term used to describe the different techniques for controlling or improving the health of the cassava plant. There are many techniques, but let's just take a moment to describe 3. First off, the most basic, practical, and cost-effective treatment is called crop hygiene. Crop hygiene is when farmers take the time once a crop has been harvested to remove any excess debris off of all the plants so that they can start fresh. The benefit to this technique is that it gets rid of almost the entire probability of transmission from old, possibly infected cassavas to newly planted seeds or roots. While it is a very effective method, it is very time-consuming and has not been put into practice by many farmers, who would much rather just harvest the plants that were productive and plant new ones in their place, which adds to the transmission of ACM. A second technique that has been experimented with is using ACMV-free planting material. Oftentimes, farmers will breed new plants by planting the hardwood stems of previous parent plants. This is a very effective technique for the production of the cassava plant, but it does not keep the virus from spreading because the parent plant could have been infected and is now creating a new infected and contagious offspring. However, there is now technology and certain tests and treatments that can be used to produce ACMV-free planting material. One of these treatments is heat therapy, which is sterilize the material. The only con for this method is that it is very expensive. Most plantations and farmers do not have the resources to perform this procedure for every planting season. Nonetheless, this is a technique that is high in demand at this point. The third technique is to crossbreed a cassava plant with a tree-like plant called a Manihot glagiovi mole. This has been proven to help create a virus-resistant strain of material, but not quite immune. Having said that, being able to create plants that have a higher probability of resisting a virus is a huge benefit to the farming community. This technique has come into high demand since it was created. The African cassava Mosaic virus has made a huge impact on the economy and the farming community in Africa, but has become treatable in recent years. Hopefully, these treatments and procedures can become more cost-effective and producible in mass quantities to really take this virus head-on.